Hello everyone, welcome back to Archangel RC. Merry Christmas to all. Yes, I know it has been a very long time since my last video, but you know how life is sometimes. It just keeps getting in the way and doesn't want to move over. Hopefully going forward this will be at least slightly different so that I can have the chance to get videos out a lot more often than once a year. So, moving on, I wanted to do an update on the fate of my MFE Fighter. Following the maiden flight and following endurance tests on the 9S setup with the 4kg battery pack, I thought I'd change things up by actually making it a VTOL. To that end, I ordered only part of the set for the VTOL setup as I had non-conventional plans for it and did not need the whole set. It all started back in the day with this video where you can clearly see some of the drawbacks of a 4-motor setup, and even though in this case it is not clear if a motor failed or the VTOL system just couldn't stabilize the plane, the end result, I hope you will agree, is spectacular, but was also quite worrying for me. This video got me thinking on how I could go about making a VTOL which would not suffer the limitation of having to crash if one motor fails, and so after much thought, deliberation, parts research, etc., I arrived at a 12-motor configuration for the fighter, which involved 3 smaller motors per arm spinning 7-inch props and basically acting as one, the idea being that if one should fail, there are 2 more motors on the same arm which have enough thrust to spare so they can pick up the slack and the plane would be spared a crash. They had to be racing quad motors working on 6S, and each 3 per arm would have the signal cables parallel connected to the same signal output on the flight controller. I even have spare cables running to and from the wing connectors, idea being if for some reason due to movement some pins get disconnected, there is a 3 times more likely chance that the signal will keep moving through since each one goes over 3 pins. In the flight controller I set them up as D-shot so I wouldn't have to do the standard ESC throttle calibration and would also allow for quicker stabilization. Hopefully. Preliminary calculations indicated that hover currents would be around 120 amps, so I had to pick up a Mauch 200 amp power module as well as an appropriately C-rated Tattoo battery pack. Just in case you are curious, all parts used will be linked in the video below, so feel free to check them out. Truth be told, I had been planning this build from before I even started putting the plane together, so as you can imagine, all the wiring, connectors, etc. was done in the beginning, just laying dormant, waiting for the time to come for it to be properly used. There was a bit of wiring to finish up from the wings along the carbon arms to each motor, but that went quickly. I printed out the motor mounts, including holders for the ESCs to sit below the motors. Doesn't look pretty, but if it's functional, it would be pretty awesome. Installed the 4120 465 kVt motor, which is an absolute beast. Hence why I also limited the max throttle the autopilot can use to 60% because I was afraid it would tear the nose off the moment the autopilot punched it. And so the time came for the first test hover. The plane was literally a hog, sporting the 4kg 9S forward flight battery as well as the 700 or thereabout gram VTOL battery, so that is almost 5 kilograms of batteries alone. I have not weighted it post VTOL conversion, but it should be at 12 kilograms, which is pretty heavy already. Let's say there is no weight left for a payload, but at this point I thought I'd just take it one step at a time and just get it flying first, or at least see how it is going to do. For the maiden VTOL test, I had the forward flight pack inside the plane but not connected, since at that point I had not yet installed the puller motor. It was in the plane only for weight distribution, and I had no plans to actually do a transition, only wanted to test the VTOL bit. VTOL battery was connected, plane armed, and with the props and motors spinning in the correct directions, it was time to give it a try. I applied the throttle, and you can tell even with so many motors working together, they were still having a hard time lifting this hog up. Turns out the battery pack's sag is stunningly high. It goes from 25 volts resting to 21 or lower when under load. That is a 4 volt drop on a 95C 4.5 amp hour pack. Think about that for a second, and even though the current sensor's readings are far from accurate and need adjusting, I can safely assume the current draw is more than 120 amps. As a comparison, I used the same batteries in the FMS Viper Jet 90mm EDF model, and under full throttle it barely makes a dent in the voltage. So either that is one very efficient EDF, or the fighter's setup is very hungry. Trying to punch up results in a very docile reaction from the plane, indicating it is hovering way above 50% of the capabilities of the motors, but when you lose 4 volts from the get-go, you also lose a lot of potential RPM and hence thrust that would have been available if it wasn't for the voltage sag. But putting that aside for the time being, the plane felt really soft and wobbly, or at least very much so on the yaw axis. You could actually see the plane twisting, or at least the wings, and in particular the VTOL arms. You can see them moving up and down, and this resulted in very laggy and drifting yaw control and reactions. It felt very weird, to be honest, but it was staying in the air, which was still sort of a success. After a bit over a minute of hover, I would land, with the battery sagging as low as 18 or 19 volts before landing, and it was quite hot by that time. And the relevant wiring was also warm, and keep in mind we're talking about a minute, and I'm using 10 AWG wiring, so yeah, a lot of amps going through. So there is still a lot of flex in the VTOL assembly, and any options of fixing it involved stuff I just did not want to get into, so I left it as it was. Next time out I had the intent of actually trying to do a transition, and whatever happens, happens. Really wanted to see how it will go, even with the risk of a crash. And now check this out. Just as I take off with the first pack, which was supposed to suffer only for VTOL testing before I try to do a transition in the second flight, as the plane is hovering I see smoke coming out of one of the motors, but guess what? The plane stays in the air and does not crash to the ground or start spinning like crazy, so I just landed it softly, and at that point was super happy, at least with the redundancy this setup provided. I ordered a spare motor and replaced the smoke one when it arrived. Next time out with the fighter, I had the exact same conviction as last time. It was either going to make the transition and fly, or it was going to crash spectacularly, because with 5 kilograms of batteries in there wouldn't be much left to put back together. There was no other option, and there was no point in delaying this any further. The flex in the frame was not going to go away, and I did not have an option for an even more powerful VTOL battery, which would hopefully suffer less sag under this particular load. So after doing a hover test for about a minute to make sure the new motor will not smoke or any other, I put in a fresh pack, took off, gained some altitude and flipped the switch. And imagine my surprise when it didn't fall out of the sky but actually started moving forward. Granted, it took a long while to complete the transition and for me to stop hearing the VTOL buzz, but at some point the noise stopped and the plane was in forward flight. Flew well as I could expect given the weight, but it was kinda slow. Took full throttle to maintain a good speed, and then I remembered that I had limited the throttle to 60%, but since I had the Dragon Link system set up for telemetry, I quickly connected to the autopilot through it and changed the limit back to the default 100%, and having forgotten why I set it to 60% in the first place, can any of you guess what I did? As soon as the parameters were saved, I pushed the throttle stick from 60 to 100% instantly, and can you now again guess what I heard? For a split second I heard an increase in the sound coming from the plane, because at 60% throttle it was pretty much silent, but at 100% as I started to hear it, I also heard the sound of a motor tearing out of the nose and cutting up some foam along the way. All of this is happening in less than a second, at which point I remembered why I had the throttle limited to 60%, but it was too late. I looked up and unsurprisingly saw a shower of foam plus something black falling to the ground. The plane wasn't too far and this motor is huge, so it was visible, plus it has a prop attached to it. I do have a screen recording of the telemetry on the computer, and you can see how the amp draw on the forward flight power sensor goes up, and then I heard the chopping sound, at which point it went to 0 when the motor had set itself free of all shackles holding it back. Awesome motor, and I'm very sorry to have lost it. I tried to search for it, but sadly the grass and thorny bushes in that exact area made it a fruitless effort. As for the plane, it may have been a tad tail heavy now, having lost some 400 grams from the nose, but it did not show it. Just kept flying, seemingly unfazed about what had just transpired, so I circled around and took it in for a landing, flipping the mode switch to Q hover just as it was nearing me, but by the time the motor spun up, it had touched down in a semi-VTOL, semi-normal plane landing, soft and safe. As expected, the nose was completely chewed up, but at least the motor had managed to liberate only itself, the ESC was still there. I talked to MFE later and they did confirm that the nose motor mount was indeed a weak spot on the earlier versions of the fighter, which they have since fixed. Sadly, I did not have the improved version, obviously. So at this point I put everything aside and have not really touched it since, other than getting the ESC for the MFE Hero I am building, and at this time I am unsure of what the future of this plane will be. Seems like it may not be as a multi-motor per arm VTOL, because I certainly don't feel like restoring that nose, at least not right now, and converting it back to a twin tractor model would also be a challenge due to the way in which I removed the wing nacelles. Remains to be seen what the future holds, but for the time being I'm happy the redundancy scheme worked, even if seriously underpowered with huge battery voltage sags, showing there is some merit to this scheme. Perhaps needs a stiffer frame and different motors which would draw less amps. We'll keep at it and see what I come up with. Right now though, I would like to wish all of you happy holidays, good health and all the best wishes there could be. Would also like to remind you to like and subscribe, and keep in mind there are some useful links in the video description below. Would also like to express my endless gratitude to all my Patreon supporters which stuck by me during this downtime for the channel. Your support truly is great and is much appreciated. As always, safe flying, and I will see you soon.